Very good morning. Today we are discussing about switched reluctance motor. Applying the stator pulse, then the inductance profile, positive slope, includes forward motoring, torque. Applying the stator pulse during the time that the inductance of profile has negative slope induces the regenerative braking torque. A single phase is excited every 60 degree with 4 consecutive phases excited at 15-degree intervals. The inductance of the stator pole pair corresponding phase current as a function of angular position is shown in figure. Here the position of the angle is equal to, in the first position, the current will be the rising of the magnitude variations as well as the magnetic field of intensity as variations of magnitude variations from 0 to maximum value of enhancement of the flux level as well as to the magnetic action due to the down the position value. So I already told the electrical angle 60 degree conducted in the maximum, then phase to phase sequence in this method, switched reluctance motor, and then phase and the optimization position in the second position. So that's why I mentioned the cross view and then conduction period of current value on the on position. And then low speed means it's a magnitude variations when we get the maximum torque and speed as well as the current conduction, and then due to minimize the reactance of the value and to the low speed and the forward direction of this diagram. And then switched reluctance motor torque is given by the effective torque is equal to 1 by 2 mi squared. M is the inductance slope and I is equal to instantaneous current. And then switched reluctance motors are growing in popularity because of their simple design and ruggedness of construction. They also offer the advantages of only having to provide positive current, simplifying the inverter design. Also shoot through the faults are not an issue because each of the main switching devices is connected in series with a motor winding. However, the drawbacks of this type of motor are pulsating nature of their torque and they can be oscillatory noise, although improved mechanical design mitigated this problem. Synchronous machines, this stator is similar in construction of that of an induction motor. The root can be also salient or non-salient. The fixed excitation is provided on the rotor by the either permanent or electromagnet with the number of poles equal to the poles of the RMF caused by the stator. Non-excited rotors are also possible, and in case of reluctance motor, and then the rotor gets locked to rotating magnetic field and rotates unlike induction motor at a synchronous speed. In the synchronous speed is equal to ns minus nr divided by ns into 100. Here the ns means is a synchronous speed, nr means is a rotor speed divided by rotor speed and divided by ns into 100 under all load condition. All conventional power plant used synchronous generator converting power to electric form. They operate at a better power factor and a higher efficiency than equivalent induction machines. Here the synchronous machines construction, two-pole cylindrical rotor machines. That means it's a salient pole type of the rotor. Here the salient pole type means a high speed and then it's a diameter of the diameter of the cross section value is minimum, and then axial length high. Here the turbo alternator is another one technical name of the turbo alternator in the salient pole type. That means it's a non-salient pole type. So non-salient pole type are only for 2-pole or 4-pole in the machine, synchronous machine. Here the stator containing the armature winding. Armature winding is based on that 3-phase AC supply in the input armature stator winding, 3-phase winding, star connected. And the next is a non-salient pole type. Salient pole type, it's based on that it will be projection of the pole from cylindrical rotor side to the conduction of magnetic action. Here in the magnetic field pole type, the rotating field pole type in the synchronous machine, and then maximum from 64 poles we will conduct the generation of output voltage. The cross section to synchronous machines, the relative position of the stator and rotor poles shown the motor action. Torque is developed in the direction of rotation because of the rotor poles try to align themselves with the opposite stator poles. And then equivalent circuit of the synchronous machines means first input side, that is armature side, AC source supply, and then inductance is a synchronous reactance value, and then output voltage based on that conducting the EMF voltage, as well as the and then battery source is a DC supply. It's a prime mover side, prime mover, and then rotor, and then motor resistance and field resistance, as well as the field winding. Then coupled with omega m and motor angular velocity with respect to torque developed in the motor. Then equivalent circuit of the synchronous motor, the armature coil is based in the equations in the format. Thank you.